All right, I was told that I can't move around like normal. I have to stay static for the camera. So unfortunately, I can't show off a lot of my acrobatic skills like I normally would. I know you guys are looking forward to that, I'm sure, at the end of the day. But I'm going to be talking about all of the manual work that we do as programmers. Perfect. All right. And I think that while work is a good thing, right? It's better to work than to be idle. I think we can go ahead and take it a little bit easier on ourselves. Maybe we can go ahead and teach the computers to help us a little bit more. And so I want to talk today about helping to teach the computers to help us. So the opening statement here is that as programmers, we spend way, way too much time doing very manual tasks. Our entire job is typically to automate other people's work, and there's still so much of our work that we don't automate. I would say that the amount of work that we do that is manual right now is about 90%. The computer automates about 10% of what is possible. And I would say that in the next couple of years, I'd really like to see it get closer to maybe, we're doing about 20% of the work. Right? 20% of the work that we do is actually creative. It's interesting, right? Whether it's user process or user interface design, or product design, or algorithms, that can be very, very interesting. A lot of the stuff we do is not very interesting. I think there are a lot of people who know the feeling whenever you go to debug a test, and you're not feeling up to it. And I think there's precedent. Although I think 90% to 20% sounds like a very big jump. It sounds a little bit unrealistic. But I do think that there's precedent. A long, long time ago, every CPU, for example, had instruction sets that were initially targeted towards humans. The idea was that when I designed a CPU, I would write up documentation for other humans to read so that they could write assembler for my CPU. And the problem was that computers could execute that assembler code, but they could not understand it, right? They could only run it. And so as humans, it was up to us to build up these amazing towers of complexity to run on these old CPUs. But today, nearly no CPUs are designed for humans to use, right? Raise your hand if the last time that you wrote x86 assembler. It's probably some people, right? But very, very few of us write just directly for CPUs. The CPUs are actually designed for other computers. The CPUs are designed for compilers these days. And the result of that is that we actually write very little of our own code, right? If we write maybe hundreds or thousands or tens of thousands of lines of JavaScript, if you think about how fast a CPU is, it can do billions of operations per second. And your JavaScript takes 1.5 seconds to load, right? That's billions of operations. It dwarfs the amount of code that we write by a huge margin. And actually, that's really, really nice, because I don't want to be spending my time, and I think very few of us want to be spending our time really at that low level, right? So by enabling computers to actually write our code for us, we've freed ourselves up to focus on things that matter much, much more and are much more interesting. Not only that, but we've taught them so well that typically, not only do they write the code faster than we would, but they typically write it better, right? It would take me a long, long time to figure out all of the nuances of how the CPUs work in order to actually outperform compilers. Another example of this, I think that is probably maybe near and dear to a lot of our hearts, is Babel. So with compilers, right, compilers enabled computers to write code for us. What Babel did is made it so that computers can actually read our JavaScript code. Right? Previously, it was that we had JavaScript engines that could run it, but they couldn't really read it. They couldn't reason about it at all. But now we do. And imagine life. I mean, this is all very fresh in our minds, right? Life before Babel and life after Babel is remarkably different. And I would say remarkably better. Right? There are so many nice tools now because we've taught the computer how to read the code, right? Turn it into an abstract syntax tree, pass that around to libraries, and suddenly we can experiment with different syntaxes, right? We can try things very, very easily as a community without having to get the entire standards body on board. And so this has enabled a huge amount of creativity by teaching computers to be able to read our code. The third example here, I would say, is performance profiling. So, there's a lot of times where whenever you're getting started with your application, you're probably not keeping performance in mind. So you build it all up, you get it to work right, which is how you should probably do it. And then it comes time to make it performant. So you have to profile it. And typically, the profiling tools in the beginning are kind of text-oriented. Right? So in this case, I'm using Clojure's trace function. It's beautiful. It's great. You can see how I can see each of these nested calls. I can see the parameters and the return. I can see maybe how much time they took. And as a human, this is really, really nice. As a computer, however, the computer has this is not usable. Right? The computer is not going to be able to reason about the performance of our code given this bit of data. But now, most performance tools and profiling tools, no one actually reads the profiling data. That data is meant exclusively for computers to read. And now we have these really, really nice tools. Right? Because computers can read so much denser data than humans can, we have amazing tools that can show us, not just the stack trace, but show me where is all of my memory going right now? Right? What are the objects that haven't been garbage collected yet? Where was my program slow as I played through it previously? These tools are invaluable, and they can't exist if we have this as our basis. We have to teach the computers to do more. And I think the fact that designing exclusively for computers is really an important key here. We very often mix up these two things, where we'll do a little bit of data for a computer and then a little bit of data for a human, right? Docs or something like that for humans. And that's actually not, I think, a great approach. Because computers will actually do most of the reading, right? You read your JavaScript code once or maybe several times per day, but computers will read that millions and millions and millions of times. And computers are able to take a computer-readable version and present a human-readable version. Right? Going the other way around is very difficult, but computers can do this. And the really cool thing is that ideas that are meant or intended for computers to be able to read are then composable by humans. And if we take the previous two examples that we looked at beforehand, where computers are able to write our code for us, and they're able to reason about the performance of our code, we get a JIT. Right? And we all rely heavily in our professional day-to-day lives and as users on Jit compilers. But JITs are not meant for humans at all. Right? They have all the data is oriented for computers, and then they write these compilers write for CPUs in instruction sets that were meant for compilers, not really for humans. Being able to compose these computer ideas is incredibly powerful. And there is a place for a human-readable layer. Right? Ultimately, the reason that we do anything with computers is to affect humans somehow. So we do want to have a human-readable layer. But it should be very, very thin, and it should always be the last stage of the pipeline. And the reason is the definition of misery is trying to recover computer readability from a human-oriented system. So, the very famous example here is maybe SQL, right? SQL is incredibly powerful, and it's beautiful. The relational databases are just amazing. They have, decades, nearly half a century of research that has gone into them. And people are scared to use them in many cases because it was originally designed for a human to use. The thought was that a human would sit down at the terminal and would type in strings. And so it was very important that it would be a string-oriented language and that everything would be string-based, and kind of a nice little language. And I actually would argue that I think a lot of the reason that people were into NoSQL, for example, is because it took a computer-readable thing and then presented a human-readable version on top of that. right? String interpolation with SQL is the source of so many different security attacks, and it's just incredibly painful. Being able to compose functions in our code is something we all take for granted. But if you try to compose SQL functions from your programming language, that's an incredibly difficult thing to do. You effectively have to write a compiler. You have to teach the computer how to read SQL, or at least how to write SQL. And the other example here is maybe site scrapers. So I was at a company where I had to maintain more than 100 scrapers, sometimes with companies who didn't want us to be scraping their sites. And so I know how easy it is for scrapers to break. Because web pages are not meant for computers to read. They're meant for computers to render for a human to look at. So again, keep the human layer very, very thin. Because any amount of energy that you invest in that human layer is lost to the computer. So you always want to ask yourself, could I be pushing this down into a computer level and then maybe generating this human layer? Again, the crux of this is going from computer readable to human is much, much better than the alternative. To just drive this home, I'll take an example here. Let's say that given an API, I want to actually generate maybe some tools. I want to explore this API. I want to know what it's like. Maybe I want to generate an autocomplete tool for my editor. So these are beautiful documents, right? They're generated, I think, by README.io. Trello has taken a lot of effort, painstaking effort, to describe their API really, really well. So as a programmer, maybe you start to break it down, right? There is a pretty repeatable structure here, right? Maybe we notice that there's a list of actions over here on the left. Maybe we get out our scraper and we start breaking down the DOM, and we notice that, all right, well, there's a method and there's some paths, and I could probably write a little bit of maybe split the string on certain characters and extract the parameters. And eventually, you'll work your way to something like this. And from this, like JSON, we can all probably write a very nice autocomplete tool. But that was a lot of work to go from those beautiful despite how beautiful they were, it's still a lot of work. Whereas if you do the alternative, it would look like this, right? You would start with that computer-readable version. If your goal was to write an autocomplete tool, you would start with a thing that was computer-readable. But the documents would naturally come out of that. You could naturally generate these beautiful documents. And actually, I think that this affects us in so many different areas of our day-to-day life, and we're so numb to the pain. It's hard to even notice at times. We just go through the same motions, the same manual labor, again and again and again. Things like integration, analytics, documentation, testing, mocking, on and on and on. So I'm going to talk a little bit about integration. And integration, by its very nature, is meant for two computers to talk to each other. That is the entire goal of integration. And yet, whenever we write our APIs, we write them for a human. Right? We write them so that a human can come and read the API. Instead, what we should be doing is probably writing for the computer. Because whenever you write for a human, I can actually see how you do pagination in your API. That's great. Right? Pagination, how many different pagination strategies are there really? Right? Maybe there's page-based, offset-based, cursor-based. Right? I can't think of too many more. The amazing thing, though, is despite how few different patterns there is no one universal pagination client. There's no get me more resources client. Because every endpoint is basically human-oriented, and so the computer cannot figure out, they can't derive what are the parameters that goes into your pagination. What are the sorting parameters? What are the offsets, the distance? Whatever it is, if you put it into a form that a universal pagination client could use, then suddenly we don't need to write pagination logic one-off, bespoke, every single time. Rate limits is another really big one. Raise your hand if you have ever dealt with rate limits in some way, like say the Twitter API or anything like that. So rate limits, I think, are actually phenomenally difficult. They're quite esoteric, how to handle with them properly because of how difficult they are. So let's say that you're writing a little tool for Twitter, and what you want to do is to reach into Twitter and pull out a list of all of your tweets. Twitter, I believe, limits you to something like 100 API calls per hour. What's going to happen is you will hit that rate limit error. And now you're going to have to reach into, at the time you make an API call, you're going to have to look at the results, and rather than just expecting data to be there, you have to check for an error. And you have to check for the class of an error. Is it a rate limit error? So now you're in the rate limit world, and what do? Right, so the typical thing is just exponential backoff. It's easy enough to think about, but exponential backoff is a non-local thing. Right, I suddenly have to restructure my entire code to figure out how to accommodate the execution strategy that the server wants. Because the server is not communicating to my client in a way where the client knows how to just back off. And this actually gets really, really bad if you have more than one process or more than one worker, or you have a user who's using this at the same time as one of your workers. Because now you actually have to coordinate that backoff across all these different non-local sources. You now need to centralize and rate limit on your own side. So this is a phenomenally difficult thing that should be pushed down into the system. We should absolutely be teaching computers how to handle rate limits. Another one I think is really interesting is API analytics. So as a provider of an API, how much do you actually know about its usage? Right? And with a REST API, for example, at best, you probably know that some routes are more popular than others. But actually, let's say that you go into one of your endpoints, and you decide that you want to remove a field, or you're going to make a breaking change in some way. Or maybe even you found out that the field had a bug. And what you want to do is go and tell all of the people who were affected that they should check the validity of their data. Maybe they should refetch some new data. If you don't have a good understanding of how your API is being used, your only option is basically to email everyone and say, hey, we messed up. But maybe there are only 3 clients who are affected by that. It would be much, much better if the computer could tell you, don't worry about it, it's only these 3 clients. If the computer is able to read the usage patterns of your API, the computer can help you in these cases. It can even do things, I think, like if you know which fields are being used by which clients, it can make it so that you could actually help them migrate whenever you make a breaking change automatically. So rather than just telling them, hey, this code is about, the code that you have is going to break, December 12th. Good luck. What would be better is, I see that you're using these 4 fields. These 3 are being deprecated. They've moved over here. This is the new way to do it. And in fact, here's a function that will rewrite your data dependencies as much as possible. Documentation is one. Right, there are lies, there are damn lies, and then there's API documentation. Right? Like, they are so rarely in sync with the actual implementation because, again, they are written by humans for humans. And they should be written for computers to then write for humans. And you can even do things. If you could combine these 2 different ideas, right? Whenever I'm reading your API documentation, I'm basically at point X. And my goal is to get to point Z. That's all I want to do. Anything else is a distraction. The faster you can get me there, the better. So if you could take that computer understanding of API usage, you could say, we actually know that people like you, or early users, typically 90% of them want to do this. We're actually going to prioritize this automatically, changing over time based off of the usage, so that we best serve our users. Discoverability, just helping me know what's available. Mocking is another one. If you describe what the shape of your data is to a computer, then a computer can just generate some dummy data. I don't have to write any mocking logic. It's really nice. And language-specific clients, I actually think, are a symptom of this ultimately. The fact that there is a GitHub Node client, a GitHub Ruby client, is madness. how much work is wasted, is overlapping, because there's not a sufficient description of the underlying API to generate these clients, and then add a nice human layer at the top. So I want to show a quick demo of what that would look like. So this is actually written by a friend of mine. So this is, how many of you are familiar? Raise your hand if you are not familiar with Hugel. Everyone. Oh, OK, yeah. So most people are not familiar with Hugel. Hugel is this really cool idea in Haskell, because Haskell forces its users to describe in detail a lot of the different aspects of the language, of the libraries. And so you can generate really cool tooling. And you can say, for example, inside of this library, I have a list of integers, and I want to get one integer. What are the different functions that could do that for me? This is a similar idea. So Ramda and datefns, date functions, they have good documentation, but they are bespoke. The work that went into Ramda did not help date functions. And even with that set of documentation, there's not a tooling like Hugel. So this idea here is that I have a new date, and I want to get true. Show me all of the different functions inside of this library that could do that. Or maybe I want to say, for example, I have a list of 4 items, and the result should be 4. And it can just evaluate it and say, this is where you're starting from. This is your destination. These are the possible paths. This is such a better way. If you describe to the computer how your programming works, the computer can help you. How often have we been sitting in a JavaScript library thinking, I don't know how to get that kind of object. I don't know what you want. Like, what are the intervening steps to get there? Just tell me. I'll do it if you tell me. So we should make it so that the computers can tell us. And this is not a super new idea. We've seen this with SOAP versus REST. I think probably not so many people have had a chance to work with SOAP these days. SOAP was really good at being descriptive. You could generate clients automatically for any language from the description of the API. The problem was it was also very, very heavyweight, and so you basically had to generate clients. And so there's a master's thesis, I believe, that REST is based on. But the REST that most of us have used is not that. It is actually, I think, a bit more of a reaction against kind of the heavyweight prescriptive nature of SOAP. And so we wanted to use JSON. We wanted to move much more quickly. We could do a lot of convention over configuration. And in many ways, it did help us. In many ways, it is much, much more fun to work with. The problem was, in the transition, computers basically have no ability to read anything about your REST API. At best, there's some general pattern that you're hopefully following that you can use to generate some of your tools. And this will keep repeating itself. So there's OData versus GraphQL, and RPC versus SQL. So I want to show 2 more demos, getting to the end of the talk. I actually think that we can generate such good tooling like Hugel, much better documentation, much better developer experiences, that it actually can be dangerous. So I will show you a demo of a tool called Graphical. So Graphical is pretty amazing. It actually allows you to point at any GraphQL server, and it will generate autocomplete for you in a beautiful way. So I can explore any server. So I can come in here, and I get autocomplete at any different level. So I can say, maybe I want to go into GitHub. What does GitHub have? I see they have maybe a repo. And I get autocomplete for the different arguments that it takes. So I'm going to come in here, maybe pull out a repo. And I'm not sure what it's going to return, but it knows that it's syntactically incorrect. I can see that if I hover over it, it tells me that I get documentation in line. Right? Because it's able to introspect the API at such a deep level, it can provide amazing tooling. Imagine trying to overlay this level of tooling on your REST API. How much work would it take? how much work would you have to do if you took it to the next REST API? In fact, we can do really cool things. This is my favorite way to explore APIs now. So this is a visual tree. So I work at OneGraph. It is a GraphQL wrapper around lots of different services. And the thing is, the majority of our users don't actually know GraphQL. Because the very first thing they do is they come in here, they open up the Explorer, and they start to see what's available. So for example, Zeit. Zeit has beautiful documentation. But maybe I just want to see what's available as like a mutation. And I see I can purchase a domain in here. I can just kind of like click my way through as though it were like a file system or something. And I can fill out the arguments. And I'm going to buy, let's say, ReactiveConf 2018 demo.com and success. And I'll just run that. And it's going to take a little while, because it's actually negotiating through Zeit's API to buy an upstream domain. But I will actually soon be the proud owner, I hope, of ReactiveConf 2018. And as a developer, this is a phenomenal experience. Right? Being able to actually explore and interact with an API like this is unprecedented. Docs are dead things. It takes a lot of work to turn a document that I'm reading about your API into a thing that I can actually try. So now I own ReactiveConf 2013 demo.com. Or 2018, I think. So I want to highlight that this is such a good experience for developers that actually there's a bit of an uncanny valley. You want to be careful. Again, there is a place for a human readable layer. And I'm going to show you, this is what the actual Zeit domain experience is like. So Javi, I think, worked on this quite a bit. He was speaking here yesterday, I believe. But I'm going to come in here and say ReactiveConf 2018. And it's going to, as I scroll, it's checking several hundred different domain TLDs. The design is beautiful. It's very efficient. Right? If I were to do this inside of that demo I showed you, it would take a long time to check 600 different TLDs. So I'm not saying that we should build tooling to generate UIs to actually ship to end users. It's inarguable that this is an infinitely better experience than clicking around inside of graphical. But as developers, that experience is still incredibly valuable. So I have one last demo, and I want to kind of do it so in a way that just brings together all of these ideas to emphasize how much manual work we do that could potentially be automated. And this is incredibly beta. This is not ready for production at all. The team has been working like mad for the past couple of days. I literally just got it working 2 minutes before coming on stage. So this is beta. It could break in some ways. But I want to show the idea. Notice here. In particular, the importance of being able to compose all of these different ideas as an end user very, very quickly. OK. So this is similar to the graphical demo. But I have this little test mode thing, so I can run it. And this stock demo, it's going to go and get the current stock price of Apple. And I can look and see what is that data. But it's in test mode, so it's actually not going to hit production. It's going to mock all of the data for me automatically. So the symbol is obviously not hello world. But this is enough for me to actually experiment with my code. Maybe I don't want to hit the production yet. Maybe I don't want to actually purchase a domain on every keystroke. But I do want to know if I'm writing an application that does something like that, I want feedback as immediately as possible. So what I'm going to do here is actually start to chain these together. So there's this idea of subscriptions in GraphQL. So I'm going to say that I want to subscribe to Twilio. And while I like typing, I think I'm going to open this up and just navigate through here. So I'm going to go into Twilio. I'm going to do a webhook URL. The idea here is that for the subscription, every time that I get a new SMS, I want you to post the results of this to that webhook URL so I can debug it. But I also want to get the information about the SMS. So given the SMS, I want the body, I want to know who it was from, and who it was sent to. And in this case, I'm going to go look at my Twilio number. All right, so this subscription is now set up so that it's going to automatically get called every single time this phone number gets an SMS. And the idea is, like, maybe now what we want to do is act on that in some way. So I say that I'm actually going to go into Zeit, where I have a lot of my domains. So I'm going to give them a title real quick. Twilio, coming SMS, to, from, and body. I'm going to give this a name, Twilio SMS. We'll open up a new one. We'll call this Zeit domains. What I'm going to do is go into Zeit. I'm going to get a list of my domains. So these are all the domains that I've already purchased. And for each of the domains, I'm going to get the name and when I bought it. But what I'm actually going to do is make it so that this takes a variable. And do domain name. It's a required string. And I want to know, is this domain available? So that's going to be a domain name. And get whether or not it's available. And while we're at it, in case it is available, I want to know the price of it. OK, so I can click through that. And now what I want to do is actually tie these two things together. So I'm going to say that this Zeit domains relies on the Twilio SMS. And as I come in here, again, remember, this is all just mocked out. And so I'm going to say that I want to return the Twilio SMS data dot Twilio. Let's see. Twilio dot incoming SMS dot from or body. So now what I can do is the text from the Twilio SMS is going to flow into this variable, and it's going to go and execute this domain's query. And if the domain is available, what I'm going to do is actually tie this into now. Whoops. All right, so we'll just skip through that. So we can actually tie that into, so imagine that's still there. But we can tie that into a GitHub repository now. So same idea. I actually want to go into GitHub, and given the domain name, I want to do GitHub, create a repository. And the input is going to be the name of this repository is the thing that I texted in from SMS. And I'll just get the repository ID. The next thing I would want to do is go into Zeit and actually do a mutation here. So Zeit allows you to do to create deploys. So what I'm going to do is actually purchase the domain. The expected price is going to be the domain price that we saw earlier. And it's going to be the domain name. And we'll get whether or not it was successful. Now again, I'm going to run over here, and we'll do another mutation in Zeit. And what I want to do is actually create a deployment. And this is pretty cool. The way you can do this, you can actually say that I want to upload a file directly from this query. So the project name is going to be the same, domain name. And the list of files is this. And the file is going to be index.html. And the data is going to be welcome. And we'll get the idea and the ready state in case we need it later. And finally, I'm going to associate that domain I just bought. So this is a mutation. So we'll alias the deployment that we just created. The deploy ID will come from the previous query. And the alias is going to be the domain name that we had earlier. And we'll get the UID. And now we're almost finished. We have a pipeline where from a text SMS, I can text it. It'll go and see if a domain is available. It'll buy it. It'll create a GitHub project for me automatically. It'll create a Zeit deployment with a default index.html. It'll associate that domain. And now the last step is to send a reply. So we want to go into Twilio, send a message. And what we do is we send it back to the original from in the original query. And the idea is, although this is, like I said, super beta, and the UI needs a lot of work and whatnot, the idea is a lot of the applications that I have built over the past 10 years could be built in something like this, with the computer helping me in about 5 minutes. There is so much work that I do that I would much rather the computer does. So I have a final call to action for you here. Please start making your APIs self-documenting and self-describing. Whenever you are writing docs for a human, maybe start with data instead. Start with something that the computer can read, and see if you can generate those docs that you are going to write. And then, once you've started doing that, you can take a look at actually how many tools exist. What are the pros and cons of the tools that are out there already that do this? Things like Swagger. Or I would recommend just use GraphQL, in which case I can just point my service at it, or anyone can point their graphical at it, and I can compose all those different ideas together in a way that is not possible if it's only written for humans. Thank you.
Well, that was frighteningly impressive. All right, do we have time for some questions? I'm not sure, we don't have a timer here. We do. When should one decide to use Elastic SQL DB instead of cluster of single DBS?
Well, I mean, it depends on how many, gigabytes you need to frog per second, I guess. I don't know. No, I don't know. Elastic SQL? Probably way later than you think you do. Yeah, way later.
All right, concise. How to use custom GraphQL types imported for NPM package in Apollo's GraphQL.
So this is actually a major sore point. So for those of you who don't know, GraphQL APIs are self-describing. You have to tell the computer, here are all my fields, here are the documentation strings on them, here are their types. But that is limiting, because GraphQL only has certain kind of types built in, strings and integers and lists and associative lists and that kind of thing. And so sometimes it's nice to be able to say, this string is not just a string, it's a date. And to be able to deserialize it into a date automatically on the other side. But the really big problem here, whenever you do that, a custom data type as it exists in GraphQL right now does not have to be represented as one of the underlying types. And so that means that it's now an opaque blob. The computer does not know how to deal with it in an automated way. You actually have to tell it how to deserialize this blob now. And most services, most applications don't handle custom types in Apollo well at all. So there is some work right now there's a discussion in an RFC for GraphQL that is arguing, really, although you can have a date, you should still at least describe that it's implemented in terms of a string. So if I'm just writing some middleware, at the very least, I can pass through it, and I can do a little bit of work on it, and then I don't break just because this is an opaque blob. So I would say that we don't handle it very well, or we don't use it very well right now.
OK. You showed a tool to find a specific method we can use. What was that?
This was a tool by Matti. He's sitting down here in the front. You should come talk to him. He's like literally how you use it. Yeah, but the idea there is actually that any library that would write its data in a way that this tool understood would automatically work with that with no additional effort. And so, yeah, it would be really cool to see this tool get some more love. I'll actually post a link to the demo of it after the talk.
OK. What did you use to see options for Ramda?
We used the tool. So what we did is we built this tool that, or not we, Matty built this tool that took a data description of the API and then was able to see all the things that were there. So the documentation, it could run eval, could do a lot of different things. So we did the manual work. We went and, or Matty did the manual work. He went and read all of the docs for Ramda and encoded it in a computer-readable version. And so that is the tool that we used.
What about corner cases, possible exceptions, different accepted values, etc.? An API accepts if you get rid of docs.
Well, I think it's a decent question. So I typically write in a language called Reason, as Jared talked about earlier today, and I think David yesterday. And languages like Reason are really good at saying, nope, no exceptions. You have to deal with this. How do you deal with this? You can't just punt. You can't just say, well, I'll just describe it to a human, because the computer can't read it anymore. And one of the things I really like about Reason is how much the computer can read the code and how much it can help me as a result of that. So I would argue that a lot of the times there are exceptions or corner cases. There may be some decent reasons for it, but oftentimes it's for a lack of kind of understanding the underlying model. And it's better to try to minimize those. If you have to have them, then go ahead. Right? You can have those opaque things that the computer can't read. But like I said, be careful, because anytime you do that, if you don't describe it in a way that a computer can read, that's lost effort. Right? That exists in your head and in a convention, and any of your coworkers or future coworkers don't know about that. Whereas if the computer knows, it can tell everyone forever.
All right, final question. Sounds very Clojure-y, Datalog spec EDN. Was it your inspiration?
Yes, I'm a huge fan of Clojure. I worked in Clojure professionally for many years. I really like the data-oriented approach. And Rich Hickey has talked about this at length. He speaks very eloquently about it. I'm a huge fan of these things. It wasn't necessarily my inspiration for this, because I think actually even for Clojure, a lot of the things could be done in a more automated way. So there's a new Clojure documentation site by Martin that is, I believe, more data-driven. And I think that we're going to see some really, really interesting things happen as that community, even that community, which is already leading in many, many different ways, as they begin to adopt more data-driven tools, we're going to see even more interesting things come out of there.
All right. Thank you very much, Sean. Let's give him a round of applause.